Today, we're going to put on our detective hats because we are investigating one of the biggest, and I mean biggest, unsolved cases in the entire universe.
So let's just jump right in with a question that honestly sounds like it's straight out of science fiction, but it's not. This is the central mystery of modern cosmology. I mean, what if everything we see, everything we've ever known, is just a tiny fraction of what's actually out there?
Okay, so take a look at this. This is, believe it or not, the current recipe for our universe. And the truly mind-blowing part, look at that tiny little sliver right there. 5%. That's everything. Every star, every galaxy, every planet, you, me, this device you're on, it's all in that little slice of normal matter. The other 95%, well, that's where our mystery begins. It's made of dark energy, and our prime suspect for today, dark matter, which makes up a whopping 27%. So how did we even figure out something was missing in the first place? Well, this right here is our cosmic crime scene. When astronomers looked at galaxies, they saw something that should be totally impossible. They're spinning way, way too fast. I mean, so fast that based on the gravity of all the stars and gas we can see, the whole thing should just disintegrate. Stars on the outer edge should be flung off into deep space, but they aren't. They're holding together. Something invisible has to be holding them in.
So, that's the mystery. Let's follow the clues piece by piece, just like a detective, and see how scientists went from that one strange observation to this whole idea of an invisible substance holding our universe together.
You know, this case file actually goes back almost a century. Way back in 1933, an astronomer named Fritz Zwicky was looking at a massive cluster of galaxies and realized, wait a minute, these things are moving way too fast to be gravitationally bound. He was the first to propose there must be some dunkle Materie, that's German for dark matter, creating extra gravity. Now, for decades, the idea was kind of on the fringe. But then, in the 1970s, the incredible astronomer Vera Rubin provided the evidence that blew the case wide open. Her precise measurements of how galaxies rotate were undeniable proof that this missing matter problem was real and it was everywhere.
And really, this quote from NASA just nails it. It's the invisible glue. You can also think of it as a kind of cosmic scaffolding. It's this huge invisible web that the entire visible universe is built on. Without that extra gravity for dark matter, those beautiful spiral galaxies we see in pictures, yeah, they would have just flown apart billions of years ago.
So, just how much of this invisible glue are we talking about? Get this, 85%. And to be clear, that's 85% of all the matter in the universe. So for every single particle of stuff we can see, there are more than 5 particles of stuff that are completely invisible. Dark matter isn't just some minor ingredient. It is the main event.
Okay, the big question, right? If you can't see it, how in the world can you be so sure it's there? Well, it's kind of like trying to find a bowling ball on a trampoline in a pitch-black room. You can't see the ball, but you can see how it warps the surface. We do something similar thanks to Einstein. He showed us that massive objects literally warp the fabric of space-time, and that this warping bends light. So even though dark matter is invisible, its immense gravity acts like a giant cosmic lens, distorting the light from galaxies behind it. And we can see that distortion. And this lensing effect led to what many scientists call the smoking gun, the bullet cluster. What we're looking at here is a colossal cosmic car crash, 2 galaxy clusters that flew right through each other. Now, the normal matter, mostly hot gas, smashed together and slowed down. But when scientists mapped where most of the mass actually was using gravitational lensing, they found it had just sailed right through the collision without stopping, like a ghost. I mean, think about that. The visible stuff is in one place, and the source of the gravity is in a completely different place. It was just incredible, direct proof.
All right, so the evidence is pretty overwhelming at this point. The question is no longer if dark matter exists, but what on earth is it? So, let's bring in the lineup of cosmic suspects.
And this lineup is, well, it's pretty wild. The ideas are all over the map. For a long time, the favorite was something called a WIMP, a weakly interacting massive particle. Basically a big, heavy, slow-moving particle. On the total opposite end of the spectrum, you have axions, which would be unbelievably lightweight. And then there's a third, totally different idea. Maybe it's not a new particle at all. Maybe it's a huge swarm of ancient black holes that formed just moments after the Big Bang.
And if you thought that was strange, hang on. Some of the more exotic theories sound like they're straight out of a movie. We're talking about concepts like a dark dimension, a whole parallel reality filled with its own dark particles and forces that only interacts with our universe through gravity. I mean, it is just incredible stuff to even imagine. So, you've got a crime scene, you've got compelling evidence, and you've got a list of really different suspects. How do you actually catch one? Well, that brings us to the global manhunt, which is happening on 3 distinct fronts. So strategy number 1 is basically to set a trap and wait. It's called direct detection. Scientists build these incredibly sensitive detectors deep underground in old mines to shield them from cosmic rays, and they just wait for the tiny chance that a single dark matter particle will drift through and bump into one of their atoms. Strategy 2 is indirect detection. Instead of looking for the particle, they look for the aftermath of a dark matter collision. The idea is that if 2 dark matter particles smash into each other, they'll annihilate and produce a flash of gamma rays we can see. And finally, strategy 3. If you can't find one in the wild, try to make one. At places like the Large Hadron Collider, they're smashing protons together with unbelievable amounts of energy, hoping to create a dark matter particle right there in the lab. So, with this massive global effort, these deep Earth labs, powerful space telescopes, giant particle colliders, you'd think we'd have caught our culprit by now, right? Well, no. The suspect remains at large. The case is very much still open, which brings us to the final part of our investigation.
First, a really crucial point of clarification. You hear dark matter and dark energy all the time, and it's so easy to mix them up. They are not the same thing. Not even close. Here's the simplest way to remember it. Dark matter pulls. It's the attractive force, the cosmic glue holding things together. Dark energy pushes. It's this mysterious repulsive force that's making the whole universe expand faster and faster. One pulls, the other pushes. 2 completely different mysteries.
And now, for the last big plot twist. What if we're hunting a ghost? What if there is no dark matter particle defined? A small but very persistent group of scientists argues that the problem isn't missing stuff. It's that our theory of gravity is wrong. This idea, called MOND, suggests that maybe gravity just works a little differently over these vast cosmic distances. It's a fascinating idea for sure. But for now, these alternative theories have a really hard time explaining all the evidence, especially things like the bullet cluster.
So really, here's the bottom line. The search for dark matter isn't just some abstract puzzle for physicists. It's one of the most important questions out there. Because whatever the answer turns out to be, a new particle, an ancient black hole, or even a new law of gravity, it will fundamentally rewrite our understanding of reality.
And that's the thought to leave you with. Solving this cosmic detective story won't just close a case. It'll be like turning on the lights in a vast, dark room for the very first time. We'll finally see the invisible architecture that has shaped everything we see and everything we are. The hunt continues.